Okay, on Thursday, we saw the changes to A and C. A and C can be found in standard form. Today, we're going to be looking at the changes of H and K. H and K is found in vertex form. So we're going to, half of this is still covering A and C. So if you were still a little bit confused on A and C, you'll get to see, we'll get to see that again. Now, H and K, that is found in vertex form. H and K are the variables that are used to define the vertex. It's still an X and a Y value. It's still an X and a Y value, but since you cannot add another X and another Y into standard form or vertex form, we had to label the vertex as HK. We had to end up labeling the vertex as HK. Now, what part of the parabola is the vertex? If I have a parabola facing this way, or if I have a parabola facing this way, what would be considered the vertex?
The minimum and the maximum.
Break that down a little bit more.
The highest point and the lowest.
Correct. The lowest point on the parabola or the highest point on the parabola. So we're talking about this point and this point. The lowest or the highest. Now, A is still part of the vertex form, but we had seen A before. We saw A when we were looking at the changes in standard form. A for the parent function is what kind of number? What is the value of A for the parent function? What is the value, the number for A on the parent function on this graph? What would the value for A be? No. Look at A, look at the sliders. It has an actual number on it. A is 1. A is 1. The value of A is 1. This one is the standard form. A is 1. Okay. A is responsible for two things. We're going to go ahead and fill this part in right here. And just so we kind of always have a general idea of where to find A, I'm going to put an equal sign here and my X minus. We're always going to find A in between the parentheses and the equal sign. We're always going to find A in between the parentheses and the equal sign. Now, if we're increasing that number, that means we are increasing it from 1. What happens if this number is greater than 1? What happens to the parabola? What does it do to the parabola? It gets skinnier. It gets skinnier, starts to close in, and it starts to close in so much that it looks like it's becoming what type of line? A vertical line. So we call this a vertical stretch. Narrow means skinny, and this is called a vertical stretch. Make sure you highlight the term vertical stretch because that's the one that they're going to be using on the STAR test. Now, if it's less than 1, with A, it has to be between what two numbers? Between what and 1? 0. In between 0 and 1. What kind of numbers do we find between 0 and 1?
0.5.
Or decimals or fractions. If that number becomes a decimal or a fraction, what happens to the parabola? It gets wider. It gets wider. Notice, smaller fraction, smaller fraction, smaller fraction. It just becomes a horizontal line. So what would we call this? A horizontal stretch. Wider. Horizontal stretch. Now, A can also be a positive number or it can be a negative number. What kind of effect does having a negative sign on A do to the parabola? It would flip it. If you have a negative in front, all it's going to do is it's going to flip the parabola over. So we always have to look at A separately. You have to look at the number separate from the sign. That only applies to A. So if it's a positive, your parabola is going to be opening up. If it's negative, it'll open down. But what term do we use? when it flips. It reflects. And it'll reflect over which axis? Always specifically the x-axis. Specifically the x-axis every time. Because I told you guys on Thursday, they will throw in a couple of answer choices that say y-axis just to trick you, okay? Now, in the parentheses, inside the parentheses, we find the variable h. So it would look like x minus h squared. This is the variable that is responsible for translates. And we will figure out what two directions it translates to. One of the hardest things for our students to understand is that this minus sign already belongs to the formula. It belongs to the vertex form of the equation. So you have to think about it as the opposite. You have to think about it as the opposite. So let me go back up. The vertex for your parent function is where? This is my vertex. It's at what? 0, 0. So my value of h is 0. My value of k is 0. X, y, h, k. So let's go ahead and fill this, the rest of this in. 0, 0. That 0 represents my value of h. H is just another way of naming the x value of the vertex. It's just another way of having a name for the x value of the vertex. But let's take two different types of examples. First example, if we have a positive 3, 2, this is if my vertex is 3, 2, where h is a positive number, when I plug it into x minus, it has no effect on this minus sign. You simply insert the number and everything else stays the same. So it would be x minus 3 squared. The other example, the opposite example of this would be, say, for example, we insert a negative 3, 2, where the value of h is negative 3. If we insert a negative number, into a formula that already has a minus sign, x minus, negative 3, what kind of effect does it have on my formula? It becomes positive. So a negative number in the parentheses would be a plus 3. A positive number would remain minus the number. And that is something that we learned last Wednesday with vertex form, when we were taking the vertex and plugging it in. So if it's a positive number, it'll remain x minus the number squared. If it's a negative number, the formula should read as x plus the number squared. That part of the formula at least. But let's see what it actually does. We said it translates. Translates in what direction? Ready? So if h is a positive number, it's going to translate which way? To the right. If it's negative, it'll translate to the left. So h is responsible for moving the vertex left and right. Positive number will move it to the right. Negative number moves it to the left. And the last variable that we have to look at is our plus and minus k. That one will always be added to the very end of the equation. It'll be next to the squared. It'll either be a positive or a negative. And let's see what this does. K, if it's positive, if we're increasing the number, what happens to the parabola? it moves up. And if it decreases, it moves down. So it is responsible for moving the parabola up and down. But with standard form, instead of K, we would see what? Plus or minus C. And plus or minus C represented what on the graph? Not the vertex, the y-intercept. We labeled it several times. We actually have labeled that plus C several times in your notes in different places. It is your y-intercept. Now, K is not your y-intercept. If you are using vertex form, this is not considered the y-intercept. Reason being is, say for example, I'm already shifted over 3. It can still move it up or down. Move it, let's say down 2, but -2 is not my y-intercept. Everybody see that? -2 is not the y-intercept. My y-intercept is probably still way up here. Okay. So all it does is it moves it up and down, but it's not the y-intercept. So that's what I'm going to write down here. Not y-intercept. It looks like the y-intercept, but it's not. It has the same type of movement, but it's not the y-intercept. Positive number will shift it up. A negative number shifts it down. So altogether, the vertex H and K, it moves the parabola left, up, down, left, or right. H and K put together can move it left or right, up or down, okay? Open up to the first example. We're either going to be filling in the information that is asked for by describing the transformation or by writing the function, okay? But one of the first things you always want to do when we're looking at transformations is to look at the vertex first. You always want to check the vertex first, because knowing what the vertex is will determine what type of function we're going to use, whether it's in standard form or vertex form. Check the vertex first. Check the vertex first. Knowing where the vertex is will determine what type or how you're going to write your function, whether it's in standard form or vertex form. Now, this first graph is just an example of the parent function. It is where all of your this is always going to be your f of x. Your parent function will always describe your f of x, where all of the parabolas start, where all of the transformations start. Then you go from there. You try to see what changes happen from dotted to solid, but you always go from dotted to solid. Now, you will not always be provided a graph, so that's why we're learning how to write the transformation based on the equation or based on the graph, and so forth. Ready? Let's look at the first example. First thing you want to do is you want to check the vertex. The vertex for this function is what? 0, 0. That is the x and the y value of the vertex for the solid line, for my g of x. Because we always go from f of x to g of x. Dotted line will always be f of x. Solid is your g of x, h of x, p of x, whatever. Now, if your vertex is on the y-axis, you're going to use standard form. Use standard form. You're going to use standard form when your vertex is on the y-axis. I'll show you. When the vertex is on the y-axis. Use standard form when the vertex is on the y-axis. Now, writing the equation in y equals form, you would simply write it as y equals ax squared plus c. This is the equation that we saw on Thursday. When we changed it to f of x form, we started with the name of the new function, which is g of x, h of x, p of x. And then the a remained the same. X squared we're replaced with what? F of x. And the plus c remained the same. We were literally only changing the numbers in front of the x squared or behind the x squared, in front of f of x or behind f of x. But the x squared and the f of x are the same thing. They are interchangeable. So what is something that you can visibly see on the graph? What kind of change? That it reflected, it flipped. So if we have a reflection, because it's described in words over here, what happens to the equation? What are we adding to the equation? A negative, a negative. Now we no longer actually use the word compression, but stretch and compression are both describing A. Now, if there is no stretch or no compression, that means that my value of A stayed the same. So that's all I'm going to write there, same A. My value of A did not change. So let's write it in y equals form and also in f of x form. So y equals x squared. Is there anything that we have to put in front of x squared? Just the negative. Just the negative. The negative is the negative in front of the x squared is responsible for the reflection. A stayed the same, so the 1 would remain the same. Let's write it in function notation. G of x, instead of the x squared, they will replace it with f of x. And all of the other changes are the same. Bring down that minus sign. That's it. G of x is equal to negative f of x. So you could see it in words. They can give you a graph or they can give you an equation and you have to come up with the words. That's why we're looking at it all the way through. Now, just because this is something that people are still missing even on the retest for the vocabulary quiz, just because of that, we need to go back over axis of symmetry. What is the axis of symmetry? What does it do to the parabola? It splits it in half. Now, because only a vertical line can split it in half, how do we describe vertical lines? With what type of equation? Yes, and x in bucks represents what? X equals. So the only way to describe the axis or the line of symmetry is with x equals. Now x equals, even though I'm writing it up here at the top with where the number 5 is, the value of x means it's crossing through x equals what? 0. X equals 0, axis of symmetry. A lot of people are still missing that. Axis of symmetry is x equals whatever number splits it in half. And I'm still getting ordered pairs as answers. So you need to go back over that. Ready? All right, the next graph is this one. Let's start with the vertex. Always want to start with the vertex. See where the vertex landed. What is my vertex? What is the ordered pair? Not 0, 0. It started at 0, 0, and then it moved to 0, -2. Always dotted to solid. But that vertex is on what? Which axis? It's on the y-axis, so we're still going to continue to use standard form. Half of this booklet, we're going to continue to use standard form. The other half, we're going to work with vertex form. So, did it get skinnier? Did it get fatter? Sometimes it's hard to tell if you actually have the physical graph, but here in the word part, it says that there was no stretch. So did we change the number for A? No, so we still have the same number for A. Same A. The number did not change, but it did flip. So what part of A did change? Correct. We put a negative in front of the A. Even though the number of A didn't change, even though that 1 is still a 1, we did insert a negative in front of it. Okay. Now, which variable is responsible for the shift? Look at your chart. Look for the word shift, K. Now, if K went down to, K would be what number? -2. If it goes down to, K is -2, which our Y value is -2. So that makes sense. Let's write this in Y equals form. So Y equals, we're still using standard form, x squared. What do we put in front of x squared? The negative. What do we put behind? -2. Let's write the new equation, g of x. Instead of x squared, we use f of x. What do we put in front of f of x? And behind? -2. If it's at the very end, it moves it up and down. In the front, it reflects or it makes it skinnier or fatter. Ready? And the line that splits it down the middle is what? And what is the equation for that one? For this example? X equals 0 because it's still in the middle. Still x equals 0. I'm just going to write it down here. X equals 0. All right, next one. Always check the vertex first. What is the vertex? 0, -1. Is 0, -1 on the y-axis? Yes or no? Yes, so we're going to still continue to use standard form, x, y. Now you can visibly see some changes. What is one of the changes that you can see just looking at the graph? It got skinnier from dotted to solid. It got skinnier from dotted to solid. Our dotted line is f of x. Notice how both of my lines are in the inside of the dotted. That means it got skinnier. So if it gets skinnier, that means there is what kind of change? An increase in A, a vertical stretch in A. So A equals 2. It changed from a 1 to a 2. What else happened to the vertex? It shifted down, and the shift comes from what value? From what variable? K. And if it goes down 1, that means that K is what? -1. Let's write in.
So the K is supposed to equal the Y?
Because it's this time, it's because it's on the y-axis. When it's off of the y-axis, K is not the y, K is no. Actually, yes. Sorry, I meant to say it differently. Yes, it is the y value, but it's not the y-intercept. Okay, but yes, it is the y value, it's not the y-intercept. All right, that's how I meant to say it. All right, so what number do we put in front of x squared? 2, and what about behind? -1. So let's write it in g of x form. Replace the x squared with f of x. What do we put in front and behind? -1. You can do it in standard form. You could do it in f of x form. Open up to the middle. Oh, you didn't finish?
When I looked at the papers from Friday,
Mm-hmm.
I was like, there are no numbers on here. And I was like, oh, don't look at me, I can look. Can I put up?
On the homework,
How do I do this?
it had numbers on the graphs.
It is?
Yeah.
Well, I mean, I
Though you
saw
mean
the
Thursday?
numbers,
You mean Thursdays?
probably.
Okay,
Yeah.
we'll look at it in a
I
bit.
didn't have that.
All right, so vertex, always check the vertex first. The vertex is 0, 0. Once again, still on the y-axis. So we still use standard form, x, y. Now, this time they gave us the equation. They want us to write what happened. It would make it easier if we switched back to y equals form. So I'm going to write y equals, I'm going to switch that f of x back to an x squared. And what number changed, or what numbers were added to that equation? A negative and 2. -2 is A, but remember, A is responsible for two different things. So the negative alone, the negative itself does what to it reflects over x-axis, always specifically the x-axis. Now the number 2 for A does what? It makes it what? Skinnier. So meaning we have a vertical stretch. Vertical stretch. And that's it for that one. If it's getting skinnier, the skinnier it gets, the more it starts to look like a vertical line. So vertical stretch. Ready? Yes, we are.
Today?
Yep. The first half of this book is just stuff that we actually covered on Thursday, which is standard form.
Then today, we're gonna finish.
Always check the vertex first. Yes, we are going to finish it today. Again, we are going to finish it today. For the last time, we are going to finish it today. So what is the vertex? Not 0, 0. 3. It started as 0, 0, but then it moved to 0, 3. Is that on the y-axis? Yes or no? Yes, so we're still using standard form. Now, in order to make it easier to understand this equation, I'm going to switch it back to y equals. H of x goes back to y equals. The x squared actually stays the same. This one's not written 100% correct. What number do we put in front? The 1/2, and behind? The +3. Okay? So the 1/2 itself is which value? A, H, or K? A. It's in front of x squared. It's in front of the f of x. So A is 1/2. And what does a fraction do to the parabola? Makes it wider. If it makes it wider, what kind of stretch? Horizontal stretch. All right. K is 3. K is a +3. So what does that do to my parabola? Shifts up. Now I'm just going to draw an arrow. Shifts up. Yep. But once again, K is not the y-intercept. In this one it is, but not always. Ready? All right, because it's about to get pretty different. Ready? All right, nobody said no. So always check the vertex first. What did the vertex change to from 0, 0? Nope. 4, -2. 4, -2. Once again, our x value is 4, our y value is -2. First, you always notate the x value, then you give the y value. 4 comes from the x-axis, -2 from the y. Now, our vertex is no longer on what? On the y-axis. So because it is no longer on the y-axis, we are now switching from standard form into vertex form. So we're going to label the vertex HK as well to help us. We are no longer in standard. We are now in vertex form because that vertex is not on this line. Does everybody understand that? Okay. So you're going to use vertex form when the vertex is not on the y-axis. Use vertex when use vertex form when vertex is not on y-axis. Use vertex form when vertex is not on y-axis. So the y equals way of writing this would be y equals x minus h squared plus k. And function notation form or g of x form. Don't forget to put the a, my bad. G of x is equal to a f of x minus h plus k. Big difference is they took the squared away and they put an f in the front. In function notation form, they don't have a squared. And there will be one that does, but that's just a typo. They took the squared away and put an F. That was it. But just slide it over. No, slide the whole thing over. Slide, grab it, grab the top, grab the, no, the black bar, black, that, yeah, move it back over. Okay, so it's in g of x form. Now we have to switch it back to y equals. G of x switches back to y equals. Instead of having f of x, we're just gonna have that x minus number squared. Now, the number in the parentheses is still gonna be the same. If it's x minus 4 here, it's x minus 4 there. If it's x minus 2 on the outside, I mean, if it's minus 2 on the outside, minus 2. That means we didn't change a. Now, I told you guys that with vertex form, the actual number will be opposite of what it is in the equation. It's minus 4 in the equation, but it's actually a positive 4, just because the minus belongs to that equation. So if h is positive 4, which way will it translate? Translates to the right, positive. And the other number that they added was negative 2. If k is negative 2, which way is it going to shift? Shifts down. If h is a positive number, that means it translates to the right. K is negative, shifts down. So we went right 4, down 2. Right 4, down 2. And our axis of symmetry is no longer x equals 0. What is it this time? X equals 4. The axis of symmetry, or the line that splits it in half, is now x equals positive 4. It goes through the x value of 4. On tomorrow's test, yes, that's why I'm going back over it. So next, always look at the vertex first. Always look at the vertex first. My vertex for this one is what? 5, 3. Once again, it's not on the y-axis, so we have to use vertex form. I'm still going to label it xy, but I'm going to go ahead and put the hk under. It's still an x and a y value, but I'm putting the hk under to help. Let's switch this back to y equals form. Y equals, instead of that f, we're just going to have the x minus with the squared. Now, what kind of numbers or what kind of symbols did they add to that equation? A negative, what else? Inside, you have a positive 5, and on the outside, positive 3. Even though it's written as minus 5, remember, a minus 5 in the parentheses represents a positive 5 value. So the negative itself, what does it do? Reflects. Just write reflects. You should know that it's over the x-axis by now. If h is 5, what does it do? Translates which way? Translates to the right. If k is 3, k is positive 3, it shifts which way? Shifts up. So our vertex went right 5, up 3. Right 5, up 3. And our axis of symmetry is now x equals what? X equals 5. X equals 5. Turn the page. This one? Let me know when you're ready. All right. Next one, look at the vertex first. What is the vertex? Negative 3, 1. Not on the y-axis, so we have to use vertex form. They didn't give us vertex, they didn't give us a function. This time we have to write it ourselves. So we can either use the words or we can use the graph, okay? Now, does it look like it got skinnier or fatter? No, it doesn't look like it. So we have to rely on the words. It does say no stretch. So did anything happen to A?
No.
Nope, same A. Now I know, and I can visibly see that the vertex moved which way? To the right? To the left 3. So left 3 means H is what? -3. And I can visibly see that it went up. So if it shifts up 1 unit, K is a +1. K is +1. So let's write this in y equals form first, x minus with the squared. We said that A stays the same, so I'm not going to put anything in the front. What number do we insert into the middle?
3.
Now, because the 3 brings in its own negative, it's going to change it to a positive. And what do we put on the outside?
1.
+1. It went up 1, so +1. The K, yeah. Outside is whatever it is. So we're going to switch that squared and turn it into an F in the front, but everything else stays the same, X. Because the 3 became +3, it still remains +3. All you're doing is moving that square to the front and turning it into an F. We're practicing writing it both ways so it does not intimidate you whenever you see it this way. Ready? Check the vertex first. What is the vertex? -3, 4. Is it on the y-axis? So we have to write it in vertex form. Okay. Now, what is one of the visible changes that you can see? Okay, so it moved to the left. Aiden said that it moved to the left. That is one of the visible changes. So that would mean translates left. That is H. If it moved left, negative. Okay, what else? What's another change? It reflected. Because it reflects, that means that we have now inserted what? A negative. And what else? It went up. If it shifts up, K is now what? +4. Can you tell by the graph that it got skinnier or fatter? No, but it also does say no stretch. So nothing else happened there. Let's write this in y equals form. X minus with the squared outside. What do I put in front of my X minus? A negative. What do I put on the inside? -3, but that -3 turns it into a +3. And what about on the outside?
4.
+4. And now in g of x form, write f of x minus, don't include the squared. So Aiden said the first thing is to include that negative. That is correct. That x minus changed to x +3. Once again, there's no squared in f of x form, and then +4 on the outside. Ready? Always helps. What is the axis of symmetry here?
1, 2.
X equals -3. X equals -3.
Oh,
X equals -3. And it was x equals -3 for the previous one as well. X equals -3. It is x equals -3 for both of these, if you haven't noticed. Okay. All right, last two, if I can find them, right here. Always check what first? Vertex. What is a vertex? Is it on the y-axis? So we write this in vertex form. If it is on the y-axis, you would write it in standard. So change it back to y equals. And this one's actually going to stay the same because this one was not written in f of x form, my bad. That's how it was supposed to be anyway. Whoops. All right, let's describe the transformation. Anything happened to A?
yes. Oh,
No, there's nothing in the front, but there's something in the inside. It's -1, but a -1 is actually what? So if H is 1, which way does it translate?
Right.
All right, and what about K? K is +2. So if K is +2, it's going to shift which way? Shifts up. Translates to the right one, shifts up 2. Vertex to vertex, right 1, up 2. From dotted to solid every time. Ready? All right, last one. Check the vertex. -3, 0. -3, 0. Once again, not on the y-axis, so we have to write it in vertex form, H, K. Now, technically, this is written in y equals form, which is what I should have done with the last one. Put a y equals here. And now we can change it into f of x form. All right, what do we put in front of that f of x? The 2. Now, because we have a +3 on the inside, what does that really mean? That it's a negative. And do we have anything on the outside? No. So that 2 is represented by, or it represents A. If A is 2, what does that mean?
That thing, right.
Yeah.
Oh, yeah.
Vertical stretch. On the inside, H is -3. If it's -3, it translates which way? Translates left.